So as you can see, my title today is Transforming Your Mineral Exploration Approach Through the Internet of Things. And I guess I feel relatively guilty about using such a buzzword, but hopefully as we go through the presentation, you'll see that it's at least somewhat justified and see what the solid theory is behind the buzz. Okay, before I dive in though, I just wanted to spend a couple of slides talking a little bit about who we are as a company and overall what it is that we're trying to do. IMDEX as a company is probably not something that you hear about a great deal, but I'm sure a lot of you have heard about our two brands. So AMC traditionally has been our drilling fluids business, but really we like to think about that these days about our drilling optimization business, and I'll explain a little bit more about that on the next slide. And then our other brand is Reflex, again really well known within the market for its survey and core orientation instruments, but really broadening out a great deal over the last couple of years into lots of other sensors as well. And you'll see on the next slide when we start talking about solution sets why we think the move to being known more broadly as IMDEX is so important. Because what AMC does and what Reflex does are really starting to merge together. The lines between them are not so clearly drawn, and indeed lots of the things that we do rely on the integration of components that come from those two brands. And this is what I'm talking about. So really within IMDEX now, we like to talk about what we do as this concept of solution sets. And it's all about, for each of these solution sets, what is it that we're actually delivering when we put out our sensors or our fluids or whatever specific piece of equipment and ancillaries that we're using. So downhole navigation, this is really very much a core of what we've traditionally done. So this is our survey instruments, our gyros, our magnetic survey tools, but it's also the hub experience that wraps around that. It's our rig alignment equipment. It's all sorts of things being stitched together. Structural geology for us traditionally has, again, as I said, been core orientation, but that's broadened out quite a lot over the last couple of years with our IQ logger and also with things like the core lifter and marking jigs and ORI auditors that allow us to improve the quality of the structural data that you're collecting. In-field geoanalysis is a real growth area for us. We started by working with Olympus to put a rental fleet of XRFs out with software and cloud data management wrapped around that. But over the course of this year, we're actually going to be releasing a series of prep equipment that will allow you to get lab quality assay data whilst you're out in the field. And we'll talk a little bit more about that towards the end of the presentation. Driller-operable geophysics is exactly what the name would imply. It's a geophysical, or in particular petrophysical probes that a driller can use rather than you needing a service provider to come out to your site. Obviously, that's all about cost benefit, but also very much about real-time data, which, as you'll see today, is a real key to what we're trying to provide. And the last one there, drilling optimization. You know, traditionally, as I said, this was all about the green and yellow buckets out on drill sites, but increasingly now we're wrapping a lot more technology around that as well, from SRUs to BOSS units, to MudAid for monitoring the fluids, which we'll be talking about today, to things like the FlexiDrill option to acquire technology that you might have seen in the market over the last month or so. So the other reason that I've just popped this slide up at the start is this presentation is structured somewhat around these solution sets. So I guess this is just a bit of a cheats guide so you understand what I'm talking about as I dive in and talk about most of these solution sets in a little bit of detail. Okay, so as I said, IoT, it's a bit of a buzzword. There's lots of others that are going around. Digital transformation, big data, analytics. I go to lots of conferences, I speak to a lot of people, and these are really big themes within the industry at the moment. But I think a key thing for me has been, well, what's the substance behind them? And I think really important question to ask all the time is not which buzzword are you going to use, but what problem is it that you're actually trying to solve, and how does IoT, in this case, help you to solve it? So that leads us to what's our first thing to resolve, and that is, Does minerals exploration have a problem that needs to be fixed in the first place? Well, the industry itself knows that it indeed does have a problem that needs to get fixed. An example of that understanding is the Uncover initiative that Mairead drove over the course of the last couple of years, where a whole lot of companies from the big end of town to the small, plus universities and surveys, all got together to start developing a roadmap on how we're going to go about exploring undercover. And the reason that they did that, well, you can see a statistic down there that 80% of our mines, of our current producing mines, were discovered more than 30 years ago. And we know that our probability of success, the rate at which we found those things, was less than 1%, which is pretty terrible. And there's a real industry fear that as we go undercover, and indeed the data shows this is the case, if you look over at the graph from Richard Shoddy that you can see on the right, that as time's going by and we're going undercover, we're spending more and more money, but we're not finding more and more, i.e. we're becoming less and less successful at exploring. So we have an industry that has an endemic problem. And then I guess the next question is, well, that's all very well, but what is it that IoT can do that helps to fix that problem? And for me, that angle is all about giving geologists data in real time so they can make good decisions. If you think about a geologist sitting out in the field right now, or increasingly a geologist sitting in their office right now, being fed data by some means from the field, what are they being expected to do? Well, they're being expected to make decisions like call the end of hole. They're being made to make decisions like, should I drill the next hole or not? They're trying to log pieces of rock as they come out of the ground. And they're doing all of that based on really pretty limited data. All they have is their visual observations of the core. Now, I know traditionally we've all patted ourselves on the back as geologists and said that was enough. But brutally, if a doctor said to you that they were going to use visual observations alone rather than all of their machines that go bing to make a diagnosis, you'd look at them pretty doubtfully, I think. So why not give geologists the data they need to make good decisions when they need to make them, i.e. in real time or in near real time? Okay, so if we dive a little deeper into what we mean by minerals exploration IoT and what benefits it can deliver, I'm going to use a pretty simple example to start off with, which is one of our survey tools, and then I guess I'll build on this case using case studies as we go through the presentation. So as I said, this is an example illustrating what the workflow looked like traditionally for one of our survey tools compared to what an IoT type workflow would look like. So you can see there that beautiful tube of metal. We challenge our marketing department here in IMDEX by having lots of tubes of metals to try and get out into the marketplace. And that tool runs down the hole, comes back up to the surface, and then the data gets downloaded onto its controller. In this case, a little yellow EasyCom. Now then, in best case scenario, a USB key might get stuck into that controller and the data will get downloaded onto it. Now, worst case scenarios, and certainly at least as common, the driller might actually just look at that little tiny screen, squint a bit, and then write the dip and azimuth from the controller down onto a piece of paper. Or, and this is a bit of a creative thing I've been seeing a bit of, they might take a photo of the screen of the controller and text that through to a geologist. So in that case, it's just the dip and the azimuth that's being transferred. From there, the data gets either typed or transferred onto a computer. It then probably gets emailed through to a database administrator who inputs it into a database where it's stored and managed and can be accessed for further use in other programs. Obviously, the contrast to that would be a data flow where the data goes straight from tool to cloud to end user, which is what we provide with IMDEX Hub IQ. So if you look at the contrast between those two approaches, well, the first one is the quality of the data that you get at the other side. If all you're getting is dip and azimuth, you're actually missing out on a great deal of metadata that the tool provides. That metadata allows you to do lots of different things, but a really big thing that allows you to do is assess the quality of that data properly. We'll look at this in a little bit more detail for one of our survey tools, But, you know, for example, things like earth rate delta for a gyro tool will help you to assess whether the tool was performing correctly or not. Then the next component to consider is chain of custody. If you think about it, then the survey data, along with the assay data, are the things that you use to create a block model, because you need to know what the grade of the ore is, but you also need to know where that ore block is. So you need to have a chain of custody on all of your data, not just your assay data. If you've got an IoT system, you can guarantee a chain of custody. The third component here is just sheer productivity and saving of people time. That first data flow has all sorts of person touch points. Now, we've already, I guess, implied the chain of custody risks with having all of those person touch points. But there's also just a sheer, as I said, productivity issue, where too many people are having to spend time to get that data to where it needs to be. And then the final piece is real time, right? You can't possibly expect to have a real-time system if you've got a system like this. There's too many people, there's too many ways the data can get held up, as opposed to completely untouched by human hands. So the data, comms willing, can be available as soon as it's been collected. Okay, so what will it look like? I deliberately used this picture not just for marketing purposes, but because it really illustrates the point that from the perspective of what's going on at the rig, in a lot of ways, not much changes. And that's actually really important. A key stakeholder in all of this process are the people drilling the holes in the first place, the drillers. They're there to provide a service, and part of that service is to provide the quality data from all of these sensors. So what you have to do for an IoT type approach to work for them is to provide them with a system that's easy to use, easy for them to use well so they can provide quality data, and easy for them to use without affecting their productivity, because their key requirement, and indeed the key requirement still of most resource companies, is that they drill in the most productive manner possible. So you can't create a cumbersome system that in any way causes that to be impacted on. But of course, underneath that rig side view, where it doesn't appear that much has changed, a great deal actually has to change. So if we have a look at what the underlying architecture you require to have an IoT system is, you can see that it's, you know, in a lot of ways non-trivial, and it's something that hasn't existed within exploration before, but something obviously that we've been working over the last 3 or 4 years to put in place. So you can see that it starts obviously with the drillers and with a series of tools that have been IoT enabled. But then you have to have a series of pieces of what we would these days call edge infrastructure. This is anything from the tablet that runs the tool to perhaps some sort of black box or on-site computing capability that allows the on-site storage of the data in instances where you can't transmit it straight away because of comms purposes, that allows some sort of access to the data to make decisions while still in the field. For example, we would allow the drillers in some instances to assess the quality of the data before they submit it, just so that they know that, you know, perhaps with the example of a core orientation tool, that they know that a core orientation has been completed successfully before they also then submit that information to the geologist. We do that so that, you know, if the driller knows that they haven't successfully completed a core orientation, then they can go and do the core orientation again on the next run before the geologist has to tell them to do that. Then, of course, you need a series of APIs that allow that data to be transferred up into the cloud and then delivered out. And then you can see that actually as part of our system, we're also developing a series of APIs that allow that data to be consumed by other parties. And this is a really important component of what we think an IoT system for minerals exploration should be. It shouldn't be a closed ecosystem. This shouldn't be all about getting your data into Index Hub IQ or something like it and that being the end of it. It should be about getting the data to where a geoscientist needs to use it. That might be an endpoint data storage system. That might be a piece of interpretive software. Whatever it is, we're very open to people working with us to allow that to occur. And I'll come back to that point in a few slides' time. Okay, so that's really what we're trying to do, and to a large extent these days already are doing. But of course, there are barriers to overcome in the industry adopting systems like this. So a big one for me is the cultural change that it implies for geoscientists. I guess this image is a little bit of a flippant one, and indeed, when I was first putting this talk together, I actually suggested to our marketing department that they go and look for pictures of grey-bearded pirate old geologists to use to illustrate my point. But I think this does just as good a job. And really, the point I'm trying to make is that geologists traditionally have been the sort of people who love to get out into the field. They love to go out and lick rocks and sit around in the bush and tell stories, maybe have a beer or two. You know, on an educational front, they're quite often the sorts of people who love science but don't love maths so much. All of a sudden, what all of the sorts of things that are starting to happen within IoT and analytics are doing is they're turning geoscientists into the sorts of people who sit behind a computer screen, consume information, and do interpretation of that data. Now, that's still a pretty technical job, and I think a pretty interesting job, but it's really a very different one to what most geologists were trained to do or what they expect themselves to do on a day-to-day basis. So there's a fair degree of disruption associated with that. And then the other component of the change is around workflows. So you can see in this slide, and we've been using this slide for a long time, starting from DTCRC days, and it's really to illustrate the point that, you know, the exploration process goes through a cycle from drilling to sampling to measuring to interpreting the data to developing a target and then drilling again. And at the moment, our expectation is that that cycle will take, you know, on average about 3 months to complete. And if you're in somewhere like Canada, where drilling is extremely seasonal, it actually might take an entire year to go around that cycle. Well, with real-time data, with the sort of thing we're talking about here, we would like to think that we could start cutting that down to days. If not, you know, in some cases, in really simple cases, maybe hours, that you drill one hole, kill the entire prospect and walk away. There are really significant flow-ons to the way exploration programs get funded within big companies, the way smaller companies go out to market, associated with those sorts of changes in the pace of workflow. So again, quite a lot of disruption, and we all know that as soon as the technology is disruptive, then adoption gets slower. Back to this collaboration piece, and I guess I look at it as both an opportunity, as I've already described, but it is a little bit of an obstacle as well. As I said, I think that for a minerals IoT approach to be successful, you really need lots of people collaborating together to give geoscientists the end-to-end workflow that they want. I've got here as an example some work that we do with collaboration partners that we already have. So obviously we collect data from our own sensors out in the field, but we also collect data from sensors of our partners. So in this case, you can see here Olympus Vanta units, where we've wrapped software around those that allows that data to be delivered up into Index Hub IQ. And then we have a series of integration partners out the other side, where we have, say, people like Acquire and Datashed, where your data can be stored for further use. We have a partnership with Leapfrog that allows your data to be pulled into a 3D viewing environment. And even internally, we have a direct integration with IOGAS that allows the interpretation of data. And it's all about this concept of real time, that you can go from collection to interpretation without anyone touching, all in real time. And the last obstacle is kind of a brutal one, and one that's to some extent out of our control, but also one that I think is going to get fixed for us. And that's communication. And I don't mean geologists talking to each other, which of course is a challenge as well. I mean just the pure challenge that most of our greenfields exploration projects in particular are quite remote, and there might not be communication infrastructure in place other than SATCOMs, which are still prohibitively expensive for lots of the applications that we're thinking about. As I said though, I really feel that the market's going to fix this for us. You can see there a picture of one of the loon balloons from Google. It's clear to me, at least, that the consumer need or enthusiasm for things like Netflix in your car, no matter where you are, means that global comms will just become a ubiquitous requirement, and we'll just follow along on that wave. And in the meantime, I guess we're looking at lower tech options. We call them mules to honour the means of transport you quite often see in places like the Andes still to get things to and from field camps. But in essence, the concept would be some sort of encrypted USB or small hard drive that allows the transfer of data between the field and the head office, so that you don't quite get real time, but you get as close to real time as you can manage, and you do still achieve a robust chain of custody. Okay, so I guess the next section is really talking about early wins. We're already doing this. What does it look like? What sorts of experiences are customers having? Is it actually helping? And as I said, I really at the start dove in looking at one of our survey tools, and I'll lap back to that as well as kind of one of the simplest examples, one of the places where we started our journey and one of the places where we're seeing really strong adoption now. We've got a couple of hundred survey instruments globally hooked up to Index Hub IQ these days, with clients using that system to deliver two key benefits basically. One is to be able to assess the quality of their survey data in real time. So if you look at the grid in the middle here with the red lines and bright red boxes, this is this point that I made before about getting all your metadata so you can assess the quality of the data. So this is for a magnetic survey tool, and you can see that we're flagging quality issues based on all sorts of things. Are the accelerometers working, i.e. do you get the correct gravity reading from the tool? Is the roll angle changing enough, i.e. is the tool actually down the hole and moving between readings as it would if it was being used down hole rather than used within a tree? And also assessments against mag field and mag dip, i.e. are you getting magnetic interference, or is the tool giving you the reading that corresponds with the location that you're at? And of course, the beauty of being able to see all of this in real time is being able to know in real time whether you can trust that survey data or not. And if you think that you've had a survey reading that you can't rely on, then you can do something about it. Or in fact, you can call the driller and ask them to do something about it. You can ask for them to collect another survey reading in 6 meters time rather than in 30 meters time. If it's magnetic interference, you can tell them to put it further out of the RC bit to get it away from the rest of the rod string. Or you can tell them to swap to a gyro tool because obviously you're in magnetic ground. So you have data, you can make decisions. Of course, the other thing that having your survey data in real time allows you to do, and by you I mean both drillers and resource companies in this case, is it allows you to monitor the progress of a hole against plan. So that again, if the hole starts to deviate significantly away from plan, you know that early so that you can have a conversation with the drillers about doing something about it rather than just watching the hole go off path and going past the point of recovery. So this illustrates the way we do it within the hub, but I also just wanted to show you how we're going to be doing this by the middle of this year using our partnership with Sequent to deliver real-time data into Leapfrog Central. So I'm just going to press play. Before I do, so the lines that you can see here are the planned drill hole traces. Now if I start the video, you can see that what it's showing occurring is all of a sudden a build-up of data coming through in shift by shift manner, illustrating both the path of the hole as the thick line and also in this case other data streams. So the gamma data in this case is the wiggly line. So you can see there the way the solid line, the thicker line, is starting to build up and show deviation away from the plan, as well as also showing you the way that the geochemical and gamma data is building up as the hole is drilled. So obviously the beauty of doing this within Leapfrog Central or another 3D viewing package is that rather than seeing one hole at a time, you can see all of your holes in context, and you can also see them within the context of the 3D geological model or any other data you have available. So that's something that we're very excited about. And just a case study to round out. This is really illustrating what it looks like in the field. So this is one of our clients operating in West Africa. They have a series of rigs drilling for them on one of their projects. They have 20 of our survey and rig alignment tools that are hub enabled, where geologists are planning the holes, pushing them down to the drillers. The drillers are then collecting data against those holes and pushing them back up so that the geologists can monitor the quality and progress of those holes in real time. And you know, even in Africa, we've actually found that the comms is more than sufficient to allow that to happen in a really effective way. And then in this case, to ensure that complete chain of custody, we also have a connection in place so that data flows all the way through to Datashed. So no one touches the data and a chain of custody is ensured. Okay, so the next of the solution sets that I just wanted to touch on was drilling optimization. So you can see that this slide really illustrates throughout the points of the workflow the different components of our solution, everything from reflex mobile to the fluids to TN14s for aligning the rig. But the component that I particularly wanted to talk to you about today was Mairead. So Mairead is something that we're just releasing out into the market now. We have a few units scattered through North America and here in Australia. And what it allows to do is for the quality of the fluid being used in the drilling process to be monitored by one of our mud technicians in real time off-site. So the contrast for exploration would be that you rely on your drillers to do this for you, and their degree of training around this sort of thing is variable. Or you rely on an AMC mud technician coming to visit you, and if your site's remote, that might only ever happen once a week or once every 2 weeks. Instead now, we have a system where the data is pushed up every 4 hours. A mud technician gets notifications that that's occurred, and they also get notifications if something has fallen out of spec. So this data is all put in IMDEX Hub IQ as well, so it can also be made available to clients to have a look at. And this is data that, for example, geologists have never seen before, but I think could actually be really interesting. But this is really just illustrating this point that, for example, in this example, pH is being monitored. You can see that it's remaining in spec for most of the shift, and then all of a sudden something happens within the chemistry of the fluid. Maybe something's happened in the hole being drilled that's caused the pH to drop out of spec. As soon as that happens, notification is sent. Mud technician can jump on the phone to the drillers and go, hey mate, you need to do something about the fluids. They've gone out of spec. Chuck in another bucket of whatever, you know. So again, it's all this concept of getting data in real time so you can make decisions in real time. Okay, so then the next solution set is structural IQ, or the collection of quality structural measurements. As I said, for us, the core of this traditionally has been our core orientation tool. This is the ACT IQ. But also now what we do is actually take data from a series of other sources as well. So we take data as well from our IQ logger, which is our device for the collection of structural data, and also from our survey tools. And we actually push all of those data sources together into the hub so that what we can do there is we can use the data from the core orientation tool to check that the core orientation was reliable in the first place. And we can combine the survey data with the structural data so that you get corrected dip and dip directions for the actual path of the drill hole. And again, we do all of that with a secure chain of custody and without any smushing of data in spreadsheets. And again, just a little bit of a case study of what that looks like in the day-to-day. This is a Brownfields Gold project here in Australia, and it really illustrates too this relationship between the drillers and geologists working together to deliver quality data. In this case, we have 3 easy gyros that are being used by the drilling contractors. They're looking at the data in the hub to make sure that the holes are being drilled to plan and to help them plan their navigational drilling. But then the geologist is also receiving that easy gyro data in their hub. They also have an IQ logger, which the geologists are using in the core farm to collect structural data. That data gets pushed up into the hub as well. The two of them get joined together. The XYZs and the corrected dip and dip directions then all get pushed through into Acquire. No one touches it, all can happen automatically, all can happen in real time, and then from Acquire, you can go and use the data wherever you want to interpret. Okay, so in-field geoanalysis, and as I said at the start, for us, this solution set is all about collecting really good quality assay data in the field, in particular preparing the sample for analysis in the field to the point that you can get as close to lab grade assay data as the sensor will allow you to do. And this is, if you talk about data sets that allow real-time decision making, obviously this is one of the big ones in terms of being able to assist with logging of drill holes and calling end of hole based on the lithology that you're within. This is actually an example though from a soil sampling program. This is some work that CSIRO have been doing recently using our equipment, our prototype equipment, and that they kindly are allowing us to share. So you can see here that they've set themselves up basically a mini lab out at their field camp. So they've got our crusher, our mule, our press, and at the end of it they've got an Olympus XRF unit running our software and pushing data up into the hub. And then from the hub, that data is actually then being pushed into IoGAS for interpretation purposes. So obviously, rather than having to wait for a laboratory to give them this data weeks and weeks, if not months later, what they're able to do is at the end of each day of the soil sampling campaign, they're able to load the data up into the system, plot it out in IoGAS, and see straight away if there are any areas of anomaly that they need to follow up on. And indeed, if you have a look at the grid of soil sample locations down in the bottom left, an area was identified on day 7 where some infill was required. They were able to go and do that infill straight away and see the results of that as well. Again, this has been possible for quite some time with portable XRF instruments. Really what we're starting to deliver here is the quality of the data by improving the quality of the prep of the sample. But the premise is the same, real-time decisions based on quality data. And then I guess finishing off on a bit of a light on the hill version of it. So this is our lab at rig technology, which is still very much a research project for us. It started its life within the DET CRC and we commercialised it out for further R&D about 2 years ago. As I said, in terms of delivering it as an automated product, it's a non-trivial exercise, but in terms of illustrating the quality of data you can gather in real time and the decisions that you make, I think it's amazing. So this is data collected within the within the MSDP project. So this was actually done slightly after us leaving the DET CRC, but obviously very strong association still with that project. We had a manual version of Lab at Rig out on site for about 6 months, collecting cuttings, drying them and analysing them off the back of an SRU. And you can see here, this is the downhole chemistry being created off of that work. And really, you can see the quote up in the top right, but the point I always like to make to geologists is with this sort of data, there's really no decision you couldn't make better than if you had the laboratory data available. And that's kind of the point. It's not about JORC compliance, it's about being able to make the best quality decision possible. And of course, there's no stopping, right? Getting data into one place is one thing. Starting to turn it into information using another buzzword, in this case analytics, is the real end game. So we call that the delivery of quantitative geology in real time. So rather than dumping a bunch of data on geologists and expecting them to then use it to log geology, start telling the geologists what we think the geology is based on that data, and then they can just fact check it, right? That's how the industry is going to evolve. An example that I'm showing here is another piece of technology that we took out of the DET CRC, wavelet tessellation. This is an approach that allows you to interpret a single trace type signature. So it's not a multi-element approach. It takes one squiggle at a time, so to speak. And it doesn't identify what rocks are, but it is incredibly good at identifying where the boundaries between different rocks are. So it allows geologists the ability to look at the core with a new set of eyes, saying, oh, I can see that the wavelet tessellation has indicated there's some sort of boundary here. What might it be? Does that correspond with something I can see, touch, or smell? No, probably not smell. Just to really describe a little bit more what these tessellation pictures look like if you're not familiar with them, I like to use a lumper and splitter analogy. So if you look, for example, at the picture in the middle here, if you're a splitter, if you're the sort of geologist who likes to get down into the fine detail and log lots and lots of different subunits, then you might look at this really detailed version of the wavelet tessellation to look for those really small features within the core. If you're a lumper like me and just want to know where the major boundaries are, then you'd look all the way over on the right. And that's really the way for you to perceive a wavelet tessellation. It gives you all sorts of levels of detail. Quite often all of them have meaning. It just depends on what your scale of interest is. And that's really my finishing point for today. So a bit of a journey from what an IoT system for minerals exploration is, what it is that it's already delivering, and then at the end there, I guess the vision and what it is that we hope to be using it to deliver over the course of the next couple of years. I'd just like to thank everyone for their time this morning. I'm going to open it up for questions now, if anybody has anything that they want to ask. If not now, then also more than happy for people to get in touch subsequent to this, and we'll help out as much as we can.